All right, thanks everybody. That was quite heartwarming. All right, I'm Stephen Kolawole, and it's so great to be here. And I'll be speaking on sign-to-speech modeling for sign language understanding. So in this talk, I'm basically going to the entire process, how I got started building it, and then the key lessons that I learned while building it. Yeah, but first of all, I think I want to give a shout out to the organizers for organizing this event. I mean, it's quite, I mean, I joined the first session and it was quite amazing. Yeah, and then I've been corresponding with some of them via mails. I think there's Alessia, there's Alessandra. Yeah, so a big thank you to all of them for putting this together. All right, so let's get started. Um, so the project started out as a fun project. So it's an end-to-end working prototype that detects sign language meanings in images and videos and generate an equivalent uh, voice of words that is being communicated by the sign language. Everything in real time. Yeah. So what I did was I wasn't conversant with sign language before. So what I did was to go to Google, yeah, and then try and learn some few signs. I think about 9 sign words, and yeah, so that was how I had my first data set to start to build the first fun project. And then yeah, it was a challenge on Twitter. There's this company known as DeepQuest, so it's an open source ML engineering platform. Yeah, so with this, I was able to win the challenge, and then so that got me thinking because as at that time I was thinking of transitioning into machine learning research. So I was like, okay, could I possibly spin this off as a machine learning research project? So the first person I talked to was my friend of AME. So she's a researcher at Data Science Nigeria. Data Science Nigeria is like one of the biggest, most prestigious data science and AI communities in Africa right now. So I talked with her, and then since she's already a seasoned researcher, so she sort of gave me tips and guidelines, and then yeah, so that's how I got started. And then based on her guidelines, I talked to my mentor. So Dr. Babs is a senior lecturer at Cardiff Metropolitan University. So with both of them, I started scoping out the projects. One thing about research projects is that you have to have a motivation, I mean, a problem space. That's, I mean, your problem needs to be, your project needs to be solving something new, I mean, something that has not been addressed by previous research works. So with them, I was able to, outline what I wanted to work on. And then, yeah, so ML Collective came in. So I don't know if anybody in the audience have heard of ML Collective before, but it's like an open science lab, where ML researchers from all over the globe, right, could come, plan, collaborate, and just do stuff together. Yeah, so ML Collective, I joined the ML Collective at the start of the project, and yeah, they were very, enthusiastic about me scaling it up as a research work, and based on the help, I think I got complete resources and yeah, other help and guidelines and feedback from them. So and finally, there is Brian Saxena. He's a math and stats finalist at the University of Toronto. He already had about 7 publications already, even as an undergrad. So he's a research partner. And then yeah, he helped me mostly with the academic writing and literature review. Okay, so moving on. In the end, we got the paper accepted into a workshop at New Rips. Yeah, New Rips is like one of the more prestigious machine learning conference, academic conference in the world right now. So we got the paper accepted as a workshop paper, and I think this was last week. SciPy sent me a mail telling me that this paper was also accepted as a conference paper in SciPy proceedings. Okay, so in this talk, now that we've covered the whole motivation and collaboration phase, so I'll go to the background, the data sets, the experiments carried out, and then finally I will try and show us a demo. So concerning the background, so we needed the motivation, and then after an extensive literature review, we decided to focus on this. And the aim is to reduce the communication barrier in the hearing impaired community and the larger society with the focus on sub-Saharan Africa. We discovered that sub-Saharan Africa is like the region with the most cases of hearing disabilities, and then it's simultaneously the region with the lowest number of solutions being targeted for solving this. Yeah, so our approach, our motivation was to try and mitigate this communication barrier in the region. So, and then based on our literature review, we discovered that the lack of solutions for this problem in sub-Saharan Africa is mostly due to two factors. And the first one is that the sign language data in the region is extremely low resource. Yeah, prior to this, there is no reproducible or substantial data set in the region, right? Yeah, so, and secondly, there are increasing complexities and advanced tools needed to deploy some of these solutions in real life environment. For example, some solutions require you making use of smart gloves, kinetic gloves, and in a region where the standard of living is a little bit lower than average, then being able to make use of these complex tools might be a far reach. So based on the motivation, we decided on following this approach. So the first step is to code a novel data set for sub-Saharan countries and language. And since I'm from Nigeria, it makes sense. And Nigeria is simultaneously the most populous country in Africa with the Nigerian Sign Language. And then assigned to test conversion experiments, several models, and finally deploy the best performing model for real-time usage while converting the sign works to test speech. Okay, so for the data set, over 8,000 images were created, right? Yeah, and we did this with the help of the TV sign broadcaster. Yeah, and then I built my first model with the TV sign language broadcaster data. And so once I had the proof of concept, it was easy reaching out to schools, I mean, special education schools in my locality. Yeah, and then request them to, help me to get a larger data set. And then, yeah, so most of them were quite enthusiastic about that. And in the end, I settled for two schools. Yeah, so in the end, this is what we had. We had a widely dispersed data set of 20 individuals captured in diverse background and lighting condition. We had to blur the faces out because there's the identity concerns now. Yeah. So for the data preprocessing, I reduced the data cleaning reduced the images to I think 5,000 images, and then since we plan on using object detection for some of our models, so we made use of label IMG, which is a graphic annotation tool. It's an open source tool, and then yeah, we made use of that to annotate the images for object detection in both text and XML formats. Yeah, so for the experiments, we tried out different models. And the first one we tried out was the YOLO V5 model, right? So I don't know if you're familiar with, anybody's familiar with the YOLO V5 model, but it's like one of the state-of-the-art object detection models right now. So we also tried out a single shot detector using ResNet 50 FPN. And finally, I discarded the annotations files and just made use of the images to build a classification model using MobileNet. All right, so for the YOLO model, I made use of text format annotations and then data augmentation methods like HSV manipulations. HSV simply means hue, saturation, and value manipulations. And then what it's doing is simply manipulating the lighting conditions, right, of the images. So, and then there's scaling, just simply zooming in and zooming out, and there's left and right flipping. Okay, so we trained over 150 epochs, batch size of 16, and so this is what we were able to have. We can say that the epoch score is almost reaching 100%. I think we have 99, and then the precision score is around 87. Yeah, so we also have the map, which is mean average precision at 0.5 IOU and mean average precision at 0.95 IOU. So what it simply means is that there's a boundary box around the sign. Yeah, so there's the true label, the true boundary box, and then the model uh, is predicting another boundary box. So we uh, try to check the overlap, or the degree of overlap between the true boundary box and the predicted boundary box. So this was at 50% overlap, and this was at 95% overlap. Yeah. And you notice that the 50% overlap is almost close to 99. Yeah. But yeah, so and then the 95% overlap is like 67% accuracy. Yeah, so for the SSD model, I made use of, I should mention that the YOLO V5 was done with Pytorch. Yeah, but for the SSD model, I had to make use of TensorFlow, specifically the TensorFlow detection API to access and fine-tune the ResNet model. The ResNet 50 was already pre-trained on the Poco 2070 dataset, and yeah, so I had to convert the image and annotations to TF record format, and for the data augmentation techniques, I only made use of horizontal flipping and then zooming, and then I trained across 40,000 steps. Yeah, so finally for the classification model, I made use of mobile NetBeats as a classifier. And then in the first trial, I only made use of 60 epochs of training using feature extraction. Feature extraction simply means that I'm using the within model mobile NetBeats as my feature extractor. So I'm only putting a single depth layer on it. So I'm not fine-tuning any of the previous layers that are contained in mobile NetBeats. And then secondly, I trained across 140 epochs of training. And this time around, I fine-tuned some of the layers in the model. Mobile NetBeats has 152 layers, and I fine-tuned the last 52 layers while leaving 100 layers frozen. So this is what I had in the end. So this green line denotes the point where I start fine tuning. Right. So you could see that the loss was crazily high. I mean, before I started the whole fine tuning stuff. Yeah. And then once I started fine tuning, it's reduced drastically, climbed up here. I couldn't explain this. And then yeah, decreased again. Yeah. So for the training accuracy, I mean that was a steady rise. So it's experienced a sharp rise. I mean over here, and then yeah. So for the recall also experienced a sporadic rise once I started the fine tuning stuff, and same as the precision. Yeah. So finally, this is my metrics table. So for the game call, you can see that the YOLO was performing best. And then when it comes to the 95% IU is also performing very well. Yeah. So the classification model also performed extremely well. I wasn't really considering classification initially, but during one of our research jams at Emma Collective, one of the seasoned researchers gave me, that suggestion to try out classification and just see maybe it performs better than my object detection models. And I think I was quite surprised to see the classification model performing as well as the YOLO model. Okay, so I deployed the YOLO model since it was my best performing model. And then I did test-to-test conversion with PyTTX3. Then I deployed the model on DeepStack server. DeepStack server is simply a wrapper around Docker. So I'm basically using Docker for my deployments. All right, so here's the demo. Okay, so in the right-hand side, I'm spinning up the DeepStack server. As you can see, I'm using Docker to do that. Yeah, and then I'm using it to point at the best performing model. And over here, I'm running the live feed detection file. And what it's basically doing is that I made use of OpenCV to open my webcam. Yeah, and then it starts capturing. Yeah. So I'm trying to use it to sign alphabets.
B C C C C D D D F, F, F,
Yeah, so right now I'm thinking of, I was thinking of trying to form a sentence with,
I, I, am, am, take,
oh,
sorry,
sorry. Okay,
sorry,
yeah.
sorry, sorry,
Okay, sorry that the old sign emotion wasn't very fluent. Yeah, I'm not yet a very fluent signer. So that means me raising up my hand is extending over several image frames. Yeah. So that means it's getting repeated. I is getting repeated like 3 or 4 times. Yeah. So one thing I want to I like calling attention to is that for the data set that wasn't part of the signer, and this particular pattern um, has never been seen before by this model. And I don't know if you can see this, but I have a light over here. And what the main purpose of the light is just to distort the image so that the model would have a hard time trying to recognize the sign. And then the model still, perform admirably despite of the, all the generalization challenges that are imposed. Okay, so moving on to some of the good blocks I encountered. The first one was that the data set creation was hectic. Yeah, this was like the hardest part of the entire process. Yeah, I had to write letters continuously to, to this broadcasting corporation before I could add that one signer. And then for the schools, I had to, go on mails receipts and then show them my proof of concepts. Then I had to borrow a lot of laptops, my friends and sisters' laptops. So we could have multiple laptops to do the data set creation at the same time. Yeah. And the data annotation was even more hectic. I had to annotate over 5,000 images by hand. Yeah. So that took us several days. Yeah. And then currently I'm trying to sort out the data set release. When I when I submitted the the work, I wrote a paper. So when I submitted the paper at this new Reefs workshop, so one of the reviewers suggested or commented on how I how do I plan on trying to protect the signer's identity. And of course, I had a handshake agreement with them, but um, I understand that stuff like that are best, put in a written agreement. Yeah, so currently I'm trying to sort out the data set release. I've not really gotten around to it yet because I've been crazy busy. Yeah, so finally, a big shout out to our collective for the compute resources grants. Initially, I was making use of Colab for my training. And if you're familiar with Colab, you know that Colab is an interactive development environment. So you have to be on it, constantly typing. And if you're leaving it for so long to train, then maybe, I don't know, in 30 minutes or in 2 hours time, it's either going to, disconnect automatically or it's going to, ask you if you're still there. So that means I think for the first training, I had to stay in front of my laptop for 13 hours straight up. Watching my model train and keep telling what's the name, collab that I'm right there. Yeah, so some of the lessons that I've learned. One thing, I think this is like the biggest for me. Most times we only need that one big project, for whatever it is you want to do. Say you're a beginner and I don't know, you want to get into the professional space or you're a startup founder or you're an academic researcher. Yeah, so most times we only need that one big project to put our names where we want it to be or, to get access to opportunities. Yeah, I could say that since I got the paper published on um, at the New York conference, I think the amount of help I've received since then skyrocketed, right? I've had people, going out of their way to help me, and I realized that, okay, most times people just want to see that potential. They want to see you do something very cool. Seeing is believing. So it's easier for you to seek your help when you've done something substantial. Yeah, and since then I've gotten quite a number of, job opportunities. Yeah, and then I've gotten mentors. I've gotten a lot of stuff to do this project. I think last month I got the AI Champion Award for the Nigerian Computer Society, and yeah, so I think that that's like my biggest takeaway from this project. Most times we just need that one big project to put on our names where we want it to be. And yeah, so and also maybe we can find out what we really want to do by getting that one big project done. So I realized that for me, I wasn't too sure on the direction I was going to take. Yeah, I mean, I have multiple skills. I could work as a software engineer with a focus on machine learning. I could work as a machine learning engineer. I could work as a data scientist. But through this project, I realized that I really want to be a research scientist. So that means that I'll be going for PhD if I really want to do that. And then, and yeah, I think I got that clarification, by working on this big project, seeing the results, and yeah. So that big project could most times define what we really want to do, in life. Also, yeah, so no need to overthink. Let's do stuff once we, have the right to do that. For one, when I started the project, I wanted to get into research. That was why I got started, right? And then when I finished the project, that was when I saw this chart by one of the more prominent researchers in US right now, and I saw this chart, and the chart is that when you start research, the first step is always reading papers, and then you try to write articles, blog articles about what you read, and then yeah, so and then you try to read papers as much as you can, and try to find that spot that hasn't been covered yet by any research, and then you try to do work in that space. And for all this timeline, I think there's like a year to a year and a half space for you to get your first research paper done. And mine was actually a little bit different because when I started this work, I didn't really know much about research. I just got started. And yeah, I had my first research paper in, I think, for 4 months. Yeah, 4 months of crazy work. Yeah. So what I'm just trying to say is you don't need to overthink most times. Of course, elaborate planning is nice, but most times I think it's easier for you to just get started, not knowing the implications or not knowing how hard it gets, than for you to, know everything that it entails, how hard things could get. And then normally, once things seems hard, then our brain has a way of getting afraid, having this flight, this flight feeling, right, to take flight, and then we start procrastinating and we don't get done on time. Okay. Finally, we can have fun and be, save the world at the same time. Yeah. I think I've seen people castigating CEOs online, trying to sell their projects or products of us, making the world a better place, when the focus is actually different. And most times, I think most people try to segregate the two. I mean, you can have fun, but fun is different from, you've been trying to save the world. I've seen people be like, okay, you can make money, but yeah, most times people trying to save the world is not always about money. But I think you could, do both at the same time. You could have the that fun you want to have, and do something nice, something that is that can be extremely useful, both at the same time. All right, so thank you very much. So if you want to check out the code and config files, or you just want to run this demo at your end, yeah, so the link is right there. And also, if you want to read the preprint on archive, yeah, the link also is right there. Thank you very much for taking your time to listen to me. And yeah.
Thank you very much, Stephen. So now we start with the Q&A session. As I mentioned before, go to slido.com, enter the keyword PyBER, like Berlin, the first 3 letters, and then ask your questions. So we already have 3 questions here, Stephen. The first question is, what was your validation train split?
Oh, yeah, for the validation train split, I made use of, for the train split, I made use of train, val, and test, right? So I made it 80-10-10, since my data set was quite large, at least to a good extent. So 80% was the training data, and then 10 was the validation. 10 was the validation, and another 10% was the test data.
Okay, thank you. The next question is, did you already develop this into a mobile app, or how do you think about deploying it to the society?
Yes, I think I got asked the same question at the Nigerian Computer Society AI Summit. So yeah, I've been thinking of deploying this as a mobile app. So I'm currently in talk with a mobile developer about it. But the thing is, I've gotten, I think I wrapped up this project late last year. So since then, I've gotten other early commitments that I, need to focus on. So I've not been working at the same speed that I've been working on this before. Yeah, but then I really thought about how to deploy it to the general populace.
Okay, I think we lost him. Stephen? Okay, thank you, Stephen.